In today's lesson, we're going to talk about surface cracks, air pockets, and craters. And these are all symptoms of the same root cause, so let's break that down. Well, there's two properties of wax that we really count on being there when we make a container candle. And the first is that the wax will shrink as it cools. As it cools. It will take up less space as it cools down. And the second property is that it will adhere to the sides. It will adhere to the jar. When it's not adhering, we call that a wet spot. We've talked about that. So that adhesion takes place here on both sides of the candle, and it will also adhere to itself on the very top. So what order does the candle cool in? So it cools in an order. First, the top and the sides will begin to cool and harden into a state. And second will be the middle, everything else that hasn't already cooled down. And it's pretty simple, right? The top and the sides are exposed to the atmosphere, to the air, and to the cool container. Anything that's cooler than it will begin to take the heat away from it. And the middle, because it's just insulated from the outside. Well, in the best case scenario, we pour our wax in, it cools down, it's a great candle, and it looks good. But when we have surface cracks, air pockets, and craters, that's actually a symptom of something going wrong. So if we take another candle here, one that didn't end up very well for us, and we pour our wax in, it will adhere to the sides, and it will adhere to the top. And that's stage one. The top and the sides have cooled. But now, as the middle begins to cool, the entire candle is going to start to contract. It's going to start to contract. And these forces are drawing the rest of the wax down towards the middle. And there's a fight between the wax that has already adhered to itself and the shrinkage that's taking place at the time. And with just a simple surface crack, this will look a little bit like this, where the top gets pulled down slightly, right? The adhesion on the sides is very strong, so it doesn't go anywhere, but the top might lose a little bit of its structure as the top gets pulled down towards the middle. And otherwise, the candle is fine. There's nothing wrong with it. The wick will stick up a little further than usual is what it looked like, but it's really not too big of a deal. This is what we call a surface crack. Okay, well, the second way that this can go wrong is that we'll have our adhesion to the sides, we'll have our adhesion to the top, but as that wax pulls down, the forces are so large, or the adhesion is not very strong, and it will actually create a separation between the top of the candle and the middle of the candle, and it will create a space here. You won't notice it from the top. The top will still stay there, but the cooling force didn't draw the top down. Maybe there is a little bit of a surface crack, but there's actually a void of space right here, a void of air, because this wax shrunk so much, it pulled that in, but it didn't pull the top down with it. And this is what we call an air pocket. An air pocket. So how does a crater form? Well, it's going to be a similar operation. We have our adhesion to the sides. We have our top. But as that force that's pulling that wax in, it's cooling down, it's beginning to shrink, becomes strong enough, it actually ends up pulling the top down with it. And maybe not in a lot of spots, maybe in a few spots, but it'll actually pull it down, and it typically happens right by Mr. Wick. The reason is that air easily travels down through the wick. It's a very limited resistance. It's easy for that air to get through because it's trying to fill that space. But the final candle will have kind of this dip or a couple dips down right by the wick, and you'll often see a lot of wax still stuck up on the wick because it adheres to it. And this is what we call a crater. You can see a crater from any candle that has it. You can just see it by looking at it, visual inspection. So what can we do about all this? What kind of options do we have in our candle maker's toolbox to prevent any of these problems from happening? Well, the first is to pour cooler. Why would we pour cooler? Well, if we think about the forces that be that are pulling this thing in, the more it has to cool, the more it's going to shrink. So if we pour at a cooler rate, we have less overall shrinking. The second option we have, and this is a popular option, is to poke relief holes. Poke relief holes. And this option typically involves taking something like a skewer and poking a hole down into the wax right by the wick, typically right near the center where the least force exists to resist the shrinkage, to poke that relief hole down the center and allow the wax to fill that. And sometimes it may require a heat gun, but this is let the wax fill the void. Might need a heat gun. You can do this while the candle is still relatively fluid, or you can do it after the fact when it has mostly hardened up, but you can do it at any point. And the third option we have is to cure in a warm environment. In a warm environment. The reason we would do this is to limit how quickly, limit how fast the top and the sides cool before the middle. How fast the top cools before the middle. This is important because if we can get the top and the middle to cool at a closer rate, then we can limit exactly how much shrinkage happens after the top has already cooled. And this can help with surface cracks, air pockets, and craters. But overall, that's the theory behind why that happens. And the most important thing to do is to take notes. Notes are going to tell you, notes will tell you your process. They will help you understand your inputs and what you're getting for outputs. If every candle you make has surface cracks, air pockets, or craters, then you know that there's something you probably need to adjust in your process. And you can consider these 3 actions when you're doing that. But otherwise, this is kind of the theory. There's nothing harmful about a surface crack, but air pockets and craters can really disrupt the way your candle burns, and in some cases cause the candle to be relatively unsafe. Now, don't be fooled by a smooth top every time. Make sure that your process is outputting good candles without any of these issues.